Hello everybody, welcome or welcome back. So today onwards, ಇವತ್ತಿನಿಂದ ಫಿಸಿಕ್ಸ್ನ ವಿಡಿಯೋಸ್ ಅಪ್ಲೋಡ್ ಮಾಡೋಕ್ಕೆ ಶುರು ಮಾಡ್ತೀನಿ. ಸ್ಟಾರ್ಟಿಂಗ್ ವಿತ್ ಫಸ್ಟ್ ಚಾಪ್ಟರ್, ದಟ್ ಇಸ್ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್. ಸೊ ಈ ಸೀರೀಸಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಇಯರ್ ಇಂಜಿನಿಯರಿಂಗ್ನ ಫಿಸಿಕ್ಸ್ ಮಾಡ್ಯೂಲ್ಸ್ ಕವರ್ ಮಾಡ್ತಿದ್ದೀವಿ. ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್, ಲೇಸರ್ ಆ್ಯಂಡ್ ಫೈಬರ್ ಆಪ್ಟಿಕ್ಸ್, conductors, superconductors, semiconductors, quantum computer, and sensors and physics of animation. ಇವೆಲ್ಲ ಇಂಜಿನಿಯರಿಂಗ್ ಫಿಸಿಕ್ಸ್ನ ಚಾಪ್ಟರ್ಸ್. ಸೊ ಈ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಇಸ್ ಆಲ್ಸೋ ಆಫ್ ದ ಚಾಪ್ಟರ್ಸ್ ಆಫ್ ಇಂಜಿನಿಯರಿಂಗ್ ಫಿಸಿಕ್ಸ್. 12th ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಇದೆ, ಬಟ್ ದಿಸ್ ಇಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಫಿಸಿಕ್ಸ್ ಆನ್ ಟು ಮೈ ಸಿಲೆಬಸ್. ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದಿಸ್ ಚಾಪ್ಟರ್. ಈ ಚಾಪ್ಟರ್ ನಾನು ಆದಷ್ಟು ಕಮ್ಮಿ ಟೈಮಲ್ಲಿ ಮುಗಿಸೋಕ್ಕೆ ಪ್ರಯತ್ನವನ್ನು ಪಡ್ತೀನಿ. ದಿಸ್ ಚಾಪ್ಟರ್ ಇಸ್ ಇನ್ಕ್ಲೂಡೆಡ್ ವಿತ್ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಜೊತೆಗೆ ನಾವು ಮಾಡೋಕ್ಕೆ ಹೋಗ್ತೀವಿ ಪ್ರಾಕ್ಟೀಸ್. ಒನ್ ಶಾರ್ಟ್ ರಿವಿಷನ್ ಆಗಿ ನೀವು ಈ ವಿಡಿಯೋನ ಉಪಯೋಗಿಸ್ಕೊಳ್ಬೋದು. ಸೊ ಫಸ್ಟ್ ಇಸ್ ನೀಡ್ ಆಫ್ ಕ್ವಾಂಟಮ್ ಮೆಕ್ಯಾನಿಕ್ಸ್. ನೀಡ್ ಏನಿದೆಯೋ ದಟ್ ಕೇಮ್ ಇನ್ ದಿ 19th century. ವೈ? ಬಿಕಾಸ್ ಈ ನ್ಯೂಟನ್ ಲಾ ಏನಿತ್ತು, ಈ ನ್ಯೂಟನ್ಸ್ law, this is not applicable for subatomics or very tiny particles, right? This is restricted to bigger particles. For subatomic or atomic particles ke ಈ ನ್ಯೂಟನ್ಸ್ law apply ಆಗಲ್ಲ. And then one more thing comes, black body radiation. First of all, black body ಅಂದ್ರೆ ಏನು ಅಂತ ಅಂದರೆ a body which absorbs and emits 100% of the radiation is known as black body. And our radiation consists of smaller subatomic particles. And ಅದಕ್ಕೆ ಯಾವ ಥಿಯರಿ ಇರಲಿಲ್ಲ which could explain the entire radiation spectrum. Idea of a black body does not exist, but a black body radiation ನಾವು ಹೇಳಬೇಕು ಅಂದರೆ it is a radiation right where 100% absorption emission takes place, absorbs and emits 100% of the emitted absorbed radiation. So this radiation consists of smaller subatomic particles, and but there was no theory which could explain the entire radiation spectrum. Then came Planck's theory. So this Planck's theory was the one who explained the entire radiation spectrum. He said that package of energy is there which is called as quanta. What is quanta? Packets of energy is known as quanta. E equals h nu. All this who gave Planck's theory only came. One more thing is light has dual nature. One is wave nature and one is particle nature. Light has two nature, one is wave nature, one is particle nature. Wave nature we can see things like interference, diffraction. In particle nature you can observe photoelectric effect. This photoelectric effect also studied in 11th, 12th also. That metal will be there, energy will fall on it when the required threshold frequency is reached. That time it emits, right? Light radiation falls on the metal has photons, and that interacts with the electron on the metal. Energy is transferred from the light to the metal, and photoelectrons come out of the metal. That is photoelectric effect. Interference, when we superimpose two or more waves, it results in an enhanced form of the wave. Superposition of two or more waves gives an enhanced form of the wave. That is interference, and that shows the wave nature. By particle nature should be photoelectric effect. Just basic example, that's it. Now coming to dual nature of matter. This was an entire chapter in 12th. So this, just like how light also has wave and particle nature, matter also has wave and particle nature. So I'm sorry for my bad handwriting. This is just basic explanation of the content, right? It's just basic explanation. One few days before the exam you want to quickly revise and then go for deep study, or just few hours before the exam you want to revise. It's meant for that. It's not for I won't write line to line, underline the notes. No, that's not this. I would like to say before itself. And this whatever I'm doing now is done by a student. I'm a student. It's from a student point of view. So forgive me if there's any mistakes. I'm welcoming all constructive criticism. So coming to matter wave, matter is nothing but material or particle. Material particle is known as matter wave. Sorry, it's known as matter. It's known as matter. Now, what is a matter wave? When suppose this is a particle which is going in this wave. When we can imagine that a particle, if we imagine this point or particle is moving along this wave, then we can call it a matter wave. Wave associated with the material or particle can be known as a matter wave. Right? Matter wave. Now there comes few characteristics of matter waves, which is important to for me to tell. Characteristics of matter wave, and this is quite an important thing. I will list 6 of them. One is that matter waves are not electromagnetic waves. Matter waves are not electromagnetic waves. The second point is that they do not have physical significance. They do not have physical significance. I'm sorry if there's any background noise. There's some noise going on down. They do not have physical significance. Matter waves are not electromagnetic waves, and they do not have physical significance. I'll explain them a bit in detail. The next point is that lambda equals to h by p, and p is momentum, h is Planck's constant, lambda is de Broglie wavelength. That is one point. Lambda is de Broglie wavelength. Fourth point is that they are complex in nature. Next, the relation, they are related by Vg into Vp equals c square. Vg is group velocity, Vp is phase velocity, c speed of light. Last point is that their amplitude represents probability of finding the particle. I will explain each of these now. First of all, matter waves are not electromagnetic waves, because electromagnetic waves can actually exist. They actually exist. But these matter waves are hypothetical. They are hypothetical. There is something hypothetical, okay? But electromagnetic waves exist. So matter waves are hypothetical. And hence they don't have any physical significance. Because they're hypothetical, they don't have any physical significance. And that's why they are complex in nature. Understood how these points are correlating? Done. Next, coming to lambda equals to h by p. P is nothing but mv. So if we decrease mass, wavelength, de Broglie wavelength increases. If we decrease velocity, also de Broglie wavelength increases. Done. Then we have two more formulas. Lambda equals h by root 2 m Ke, where K is kinetic energy, m is mass. One more is lambda equals to h by root 2 m e v, where v is potential here. If potential is known, use this. If kinetic energy is there, don't use this. If just mass and velocity is given, you can use this itself with this. Done. Next, coming to Vg equals to Vp into c square. Vp is phase velocity, Vg is group velocity, c is speed of light. Now coming more into detail of that. Vp. This is phase velocity, and can be defined as the velocity of the wave. It can be defined as the velocity with which the particle. This is not a wave, it's not a particle. I just explained right. If this is the particle, the velocity at which this particle will move along the wave is known as phase velocity. The velocity at which the particle moves along the wave is known as phase velocity, and this is given by omega by k. Omega is angular frequency 2 pi mu. K is wave number. This is angular frequency, this is wave number, given by 2 pi by lambda. Done. Next, coming to Vg, which is group velocity. Group velocity, first of all, here in the name itself group is there. So one more point is the superimposition of matter waves results in the variation. When I superimpose many matter waves, this results in variation of amplitude, something like this, and this shows amplitude of matter wave, represents probability of finding the particle. So here amplitude is high, so the probability of finding the particle is very high. That was our point here. The amplitude represents probability of finding the particle. So the amplitude is high here, it means the probability of finding the particle is high there. Done. Now I'm going to explain group velocity a bit more in definition form. So first of all, this helps in predicting the location of the particle. So obviously maximum amplitude is maximum probability of finding the particle is more there. That's fine. Vg formula, first I'll write Vg is d omega by dk. Omega is same angular frequency and this is wave number. Then coming to the group velocity, result of superposition of two or more waves, right? Result of superposition of two or more waves of slightly different wavelength. What is important here is slightly different wavelength. Superposition of two or more waves of slightly different wavelength is called as wave packet. Wave packet. So the velocity at which the wave packet, in group velocity, we are talking about the wave packet. In phase velocity, we are talking about the particle. How will you remember? P for phase, P for particle. So group velocity is the velocity at which the wave packet consisting of two or more waves of slightly different wavelength travels is called group velocity. The velocity at which the wave packet consisting of two or more waves of slightly different wavelength travels is called as group velocity. Let's given by Vg equals to d omega by dk. Phase velocity is the velocity at which the particle moves along the wave. Got the difference? Now coming to a very important derivation, that is derivation between Vg, the relation between Vp and Vg. Okay, here why should it be of different wavelength? Because they are the same wavelength, then the resultant pattern will also be the same, right? Then Vp will be equal to Vg. So that's not how it works. So that's why it should be slightly different wavelength. That's the key point also. Coming to relation between Vg and Vp. Let's start. This is much is enough. I'll just write here. Vp is omega by k. Vg is d omega by dk. I'm going to extract omega from here. Omega is Vp into k. This I will put here. So Vg equals d by dk of Vp into k using the UV rule. Vg equals Vp into d by dk of k plus k into d by dk of Vp. Just give me a second. I hope it makes this better. So Vg equals Vp plus k dVp by dk. Now what I'm going to do, I'm going to let this much be as it is. Here I will divide this by d lambda and here I will multiply it by d lambda. How I'm going to do it? Vg equals Vp plus k dVp by d lambda into d lambda by dk. This step is crucial, right? Because you're introducing d lambda here. On side note, I will write here k equals 2 pi by lambda. Dk, here I know d lambda by dk is same, but I am doing dk by d lambda. And what am I doing here? D by d lambda of 2 pi by lambda. 2 pi will keep here. Differentiation of 1 by lambda is minus 1 by lambda square. Minus 1 by lambda square. With respect to lambda, right? So this, I have to switch it now because this is dk by d lambda. I want d lambda by dk. So Vg equals Vp plus, here I will write 2 pi by lambda. K is equals to 2 pi by lambda. I have told here also. So that K equals 2 pi by lambda into dVp by d lambda into d lambda by dk. So minus lambda square by 2 pi. This is 2 pi by lambda, sorry. 2 pi by lambda. Fine. 2 pi cancels, this cancels one time. So Vg equals Vp minus lambda dVp by d lambda. This is the final derivation. I hope everything is clear. Moving on to the next important derivation. Let me know if you want these notes. I don't know how helpful these are going to be because this is tough notes. But all this will be there in your standard materials or whatever. I'm just going to my syllabus. So that will be clear. You can definitely let me know. I provided the notes. So the next important derivation. This video is a mixture of Kannada and English. So the next expression is expression for de Broglie wavelength using group velocity. What we should do? We should find de Broglie wavelength, but using what? Using group velocity. Excuse me. So Vg equals d omega by dk. Omega is 2 pi nu. D omega is 2 pi d nu. K is 2 pi by lambda. Dk is 2 pi d1 by lambda. This let's substitute here. Vg equals 2 pi d nu by 2 pi d1 by lambda. That is equals to 2 pi cancel. So d nu by d of 1 by lambda. Next, total energy equals kinetic energy plus potential energy. This we know. Then energy is represented by h nu. H nu is half mv square plus v. Here we are using standard letter v. No mgh, all that no. We are using just v. Now I'm going to differentiate this. H d nu equals 2 mv dv. 2 mv dv by 2 plus 0. See, if you're struggling a bit with this, it's totally fine. Just remember how as it is Engineer Napper coding. If you're too near to exam and not understanding, just remember it. It's just one line, right? Remember it. 2 to cancel. H t nu equals mv dv plus 0. Definition of constant achievement is 0. Okay. mv dv. Then d nu equals mv dv by h. Now we're going to bring this part here. Vg equals d nu by d of 1 by lambda, correct? This d nu we want to substitute, that is makes it mv dv by h divided by something, so into 1 by d of 1 by lambda, correct? This I will send here, Vg I will bring here. So d of 1 by lambda equals mv dv by h vg. This is also group velocity. This is also velocity. Basically velocity. So I will cancel it. Now d of 1 by lambda equals m dv by h. Now what? Now you can clearly see lambda equals h by mv, that you are able to see. But d is coming, so integrate it. On integrating, this now you can write in your own words. On integrating, 1 by lambda equals mv by h. Lambda equals h by mv. This is your de Broglie wavelength formula using group velocity. This derivation is also done. Make sure at least keep practicing the derivation, because one time you learn, the second time you might forget, but you at least know how to do it, how you did it. So Mariella, one year more nakai practice money automatically store agidate. You once go to Maritini Maritinita. Yes, chances are you Maribodo, but one in on set not content you are automatically able to do it. Try and test it and done. Next, coming to Heisenberg's uncertainty principle, that's the nila. I try to finish it in this page. The next numericals, I will begin. So Heisenberg's uncertainty principle basically in you cannot simultaneously, but snap it on the simultaneously and the accurately. These keywords. You cannot simultaneously determine the position and momentum of the particle accurately. Simultaneously accurate madakagala. Most probable madakagate ashte. So what does it say? Position and momentum of any particle cannot be determined simultaneously and accurately. Three formulas: delta x into delta t greater than or equal to h by 4 pi, delta E into delta t greater than or equals to h by 4 pi, delta L into delta theta greater than or equals to h by 4 pi. Delta x, uncertainty in position, uncertainty in momentum, and uncertainty in energy, uncertainty in time, uncertainty in angular momentum, uncertainty in angular displacement. Then we cannot find position. If you try to find position of the particle, basically we cannot find the position of the particle when the particle is moving, other when it has velocity, when it has momentum, and we cannot find the momentum of the particle or velocity of the particle when it's at rest. So, but its physical significance here in physical significance of Heisenberg uncertainty principle states that we can find the most probable value of particle but not accurate value. We can find the most probable value or value of the particle but accurate value most probable value significance. And Heisenberg's uncertainty principle states that in any simultaneous determination of position and momentum of a particle, product of their uncertainties is always greater than or equal to h by 4 pi. Heisenberg's uncertainty principle states that in any simultaneous determination of position and momentum of a particle, product of uncertainty is greater than or equal to h by 4 pi. That's it. That's it is about Heisenberg's uncertainty principle in a very just manner. Now coming to numericals. Your question and just printed format just casual I will type the question and why to waste time writing the question, all that, so that I help and I will just tell you how to solve it, and I will also check if our answer is correct. If I find out to be any mistake is there after I upload it, I will let you know in the comments, or if you find that I should have done it some other way, then do let me know. I am open to feedback. Numericals. There's two sets of numericals which you're going to cover. Set first set mugsane. So first is calculate the momentum of an electron. Momentum and de Broglie wavelength associated with it if its kinetic energy is 1.5 kilo-electron volt. I will hear the question together. Calculate the momentum of an electron and the de Broglie wavelength associated with it if its kinetic energy is 1.5 kilo-electron volt. Momentum lambda and finish ಕೊಡ್ತಾನೆ. ಇದು ನೋಡ್ ತಕ್ಷಣ ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ lambda equals to h by root 2m ke ಅಂತ. ಫಸ್ಟ್ ಇಲ್ಲಿ ಕಂಡಿದ್ರೆ ಆ ಮೊಮೆಂಟಮ್ ಕಂಡಿರಬಹುದು h by mv ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ. ಸೊ HIP ಫಾರ್ಮ್ಯಾಟಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಏನು ಅಂದರೆ SI ಯೂನಿಟ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಇದನ್ನು. ಕೆಲವು ಲಾಸ್ಟ್ ಕ್ವಶನಲ್ಲಿ ಆಮೇಲೆ ಬಂದಾಗ ಹೇಳ್ತೀನಿ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಏನಿದೆ ಅದನ್ನು ನಾವು ಜೂಲ್ಸ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಇವಾಗ. ಅದು ಜಾಸ್ತಿ SI ಯೂನಿಟ್. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಟು ಜೂಲ್ಸ್ ಟ್ರಿಕ್ ನಾವು ಪಡ್ಕೊಂಡು my trick. How I remembered as this is E comes first, J comes first, J comes second. So E a small J na big ಅಂದ್ಕೊಂಡ್ರೆ ಸ್ಮಾಲ್ ಟು ಬಿಗ್ ಹೋಗಬೇಕಾದ್ರೆ ಇಂಟು 1.6 into 10 power minus 19 ಜೂಲ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್. ಆಲ್ಫಾಬೆಟಿಕ್ ಆರ್ಡರಲ್ಲಿ ಇದು ಫಸ್ಟ್, ಇದು ಸೆಕೆಂಡ್ ಬರುತ್ತೆ, ಇದು ದೊಡ್ಡದು ಸೆಕೆಂಡ್ ಲೇಟ್ರ್ ಬರುತ್ತೆ, ಇದು ಫಸ್ಟ್ ಬರುತ್ತೆ. ಇಲ್ಲಿ ತಿಳ್ಕೊಬೇಕಾದ್ರೆ ಡಿವೈಡ್, ಜಸ್ಟ್ ಒನ್ ಶಾರ್ಟ್ ಟ್ರಿಕ್. ಸೊ ಇವಾಗ 1.5 into 10 ಕಿಲೋ ಅಂದರೆ 10 power 3 into 1.6 into 10 power minus 19 ಜೂಲ್ಸ್. ಇದು ಜೂಲ್ಸಲ್ಲಿ ಫಾರ್ಮುಲಾ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಲ್ಯಾಂಬ್ಡಾ ಈಕ್ವಲ್ಸ್ 6.62. ಇದು ಕ್ವಶನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ, ಕ್ವಶನ್ ಪೇಪರಲ್ಲಿ ಬರೆದಿರ್ತಾರೆ 6.62, 6.62, 3 6.60. ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಕ್ವಶನ್ ಪೇಪರ್. 6.62 into 10 power minus 34 by root of 2 into ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂತಲೇ ಕೊಟ್ಟಿರೋದ್ರಿಂದ 9.1 into 10 power minus 31 into Ke ಅದೇ 1.5 into 10 power 3 into 1.6 into 10 power minus 19. So using calci I am going to solve 6.62 into 10 power minus 34 divided by root 2 into 9.1 into 10 power minus 31 into 1.5 into 10 power 3 into 1.6 10 power minus 19. And yaake marking bedutte andre it's glaring a little bit and I have to show to the camera also what I'm doing. That's fine. So ರೂಟ್ ಮಿಸ್ ಆಗಿದೆ, ಎಲ್ಲೋ ಇಲ್ಲಿ ರೂಟ್ ಮಿಸ್ ಆಗಿದೆ, ಸ್ವಲ್ಪ ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕು. I will just do it quickly here. Power minus 31 into 1.5 into 10 power 3 into approximate answer is 3.16 into 10 power minus 11. Lambda equals to h by p. So 3.16 into 10 power minus 11 equals to 6.62 into 10 power minus 34 by p. So p equals to 6.62 into 10 power minus 34 by 3.16 into 10 power minus 11. Approximate answer is 2.09 into 10 power minus 23. 10 power minus 23. We are with the first question. Question number 2. Numericals part slide fast forward ಮಾಡಿರ್ತೀನಿ ನಾನು, ಯಾಕಂದರೆ ಸೊ ದಟ್ ಮೇ ಬಿ ವಿಡಿಯೋದಲ್ಲಿ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದರೆ ತುಂಬ ಅನ್ವಾಂಟೆಡ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಟೈಮ್. ಬಿಕಾಸ್ ಕ್ವಶನ್ ನೋಡಿದಾಗಲೇ ಆನ್ಸರ್ ಯು ಕ್ಯಾನ್ ಜಸ್ಟ್ ಸಾಲ್ವ್ ಬೈ ಸೆಲ್ಫ್, ಫೈನ್ ಆನ್ಸರ್ ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡ್ಕೋಬೋದು. ಮತ್ತೆ ತಪ್ಪಾಗಿಂದ ಅನಿಸಿ ಆವಾಗ ಸ್ಟೋಡಾಕ್ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಸೊ ದಟ್ಸ್ ಮೋರ್ ಫಾಸ್ಟ್ ವಿತ್ ದಿಸ್ ಪಾರ್ಟ್. ಟ್ಯಾಬ್ಲೆಟ್ ದ ಡಿ ಬ್ರೋಗ್ಲೈನ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ 400 ಗ್ರಾಮ್. ಇದು ಡಿ ಬ್ರೋಗ್ಲೈನ್ ಮಾಡಬೇಕು. ಮಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ 400 ಗ್ರಾಮ್ ವಿತ್ ಸ್ಪೀಡ್ ಆಫ್ 90 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್. ಅಗೇನ್ ಎಸ್ ಐ ಯೂನಿಟ್ ಕಂಡು ಮಾಡ್ಕೊಡ್ದು ಫಸ್ಟ್ ಟಾಸ್ಕ್ ನಮ್ಮದು. ಅದಕ್ಕೆ ದೇ ಗಿವ್ ಇಟ್ ನಾಟ್ ಎಸ್ ಐ ಯೂನಿಟ್ ಬಿಕಾಸ್ ಕೆಲವು ಡೈರೆಕ್ಟಾಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತಾರೆ ಆ್ಯಂಡ್ ದಟ್ ವಿಲ್ ಮೇಕ್ ಅ ಹೋಲ್ ಡಿಫ್ರೆಂಟ್ ನ್ಯೂ ಆನ್ಸರ್. ಇವಾಗ 90 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಇಸ್ ಟೋಟಲಿ ಡಿಫ್ರೆಂಟ್ ದ್ಯಾನ್ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ ಮಾಸ್ಗೆ 400 × 10⁻³ kg ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ವಿನ ಇದು 90 × 5/18 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಟು ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂದರೆ ಇಂಟು 5/18 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಟು ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಅಂದರೆ ಇಂಟು 18/5 ಹಾಕೊಳ್ಕೊಳ್ಳಿ. ಇವಾಗ ಇಂಟು 5/18 ಸೊ ಇದೇನಾಗುತ್ತೆ 25 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಈಕ್ವಲ್ಸು 6.62 × 10⁻34/400 × 10⁻³ × 25. ಸೊ ಇದ್ರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು ಅಂದರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 6.62 × 10⁻³ ಆಗುತ್ತೆ. Okay, moving on to the next question. Compute the de Broglie wavelength for a neutron. ನ್ಯೂಟ್ರಾನ್ಗೆ de Broglie wavelength ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು with 1/10 part of the velocity of light. Means the velocity is 1/10 of the velocity. ಇಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ಕ್ವಶನ್. Compute the de Broglie wavelength for a neutron moving with 1/10 part of the velocity of light. Mass also given, that is 1.67 × 10⁻⁻27 kg. So lambda equals h/mv. M is given, v is 1/10 of 3 × 10⁸, that is 3 × 10⁻7 because period rate is 3 × 10⁸. That gives 6.62 × 10⁻34 by 1.67 × 10⁻⁻27 into 3 × 10⁻7. Let's calculate. (1.32 × 10⁻⁻14) approximately 1.32 × 10⁻⁻14 ಸಿಗಬೇಕು. Let's go to the next question. Estimate the potential difference. Potential difference ಕೇಳಿದ್ದಾರೆ. Through which a proton, this time it's a proton, needs to be accelerated so that its de Broglie wavelength becomes 1 angstrom and the mass is also given 1.673 × 10⁻⁻27 kg. This time potential difference formula we should use as lambda equals to h/√2m eV. This time angstrom they have given, wavelength, de Broglie wavelength they have given. This we have to find out, and mass, everything else is known. So let's square on both sides first. Lambda square equals to h square by this root will go, so it becomes 2m eV. V we have to find, v equals to h square by 2m e lambda square. Now let's substitute this into this. 6.6 × 10⁻⁻34 whole square, 6.6 × -4 whole square, 2 × 1.673 × 10⁻⁻27 into 1.6 × 10⁻⁻19 into 10⁻⁻10 whole square, so it means 10⁻⁻20. Let's do this. Sorry. Approximately the answer is 0.081. Okay, moving to the next question. Particle of mass 0. Mass is given as 0.5 mega electron volt per c square, has kinetic energy 100 electron volt. Find its de Broglie wavelength and c is velocity of light. So first mass have to see 0.5 mega, so into 10 power 6 electron volt, so into 1.6 into 10 power minus 19 by c square, so 3 into 10 power 8 into 3 into 10 power 8. First let's calculate this. That becomes 0.5 into 10 power 6 into 1 into 1.6 into 10 power minus 19 divided by 3 into 10 power 8 into 3 into 10 power 8. That's approximately 8.88 10 power minus 31, and this is it. We're going to put this in as in kg, and this into electron volt, into joules. 100 into 1.6 into 10 power minus 19 joules. So now lambda equals h by root 2 mke, that is 6.62 into 10 power minus 34 by root of 2 into mass. You will not put 9.1, you will put this. We put this 8.88 into 10 power minus 31 into 100 into 1.6 into 10 power minus 19. Now I am going to ask a question, a very popular doubt in fact. In this question, why are we not using the formula lambda equals h by mv? Because mass is there, mass we can use, and we also why are we using this formula. Both answers become differently. If you use this, will come different. If you use h by root 2 mk, this answer is different, another is different. Why are we not using this is the question. Okay, let us know in the comments. So let's calculate this. 6.62 into 10 power minus 34 divided by root 2 into 8.88 10 power minus 31 into 100 into minus 90. The answer is approximately 1.24 into 10 power minus 10. Right? For this video, I'll stop up until now because I think the video length and duration is too much, and I'll continue in the next video. See you guys soon. Bye bye.